So, welcome to our webinar for moving applications to the cloud with Docker and container orchestration technology and using DevOps principles. My name is Aarno. I'm the CTO and co-founder of Vision, the DevOps company in Zurich, Switzerland. What I'm going to talk about today is, well, to motivate you why we are here. What are the issues with moving to the cloud and DevOps in general? I will motivate that by the dilemma between the traditional demo between development and IT operations, and of course bringing DevOps, explaining DevOps and my view in DevOps and what it has to do with cloud and moving to the cloud. I will introduce you to container technology, and then I will focus on what this helps you to do and what this helps you to achieve, which is hopefully beneficial to your customers as well. I will share with you a short story about Kuba, a software development company, which ported an old application to using Docker and OpenShift, and we'll introduce our product APPUiO to you, and of course share with you an voucher code that you can use to deploy your own application by yourself. This will not be an extremely technical webinar. This is meant to give you a high-level overview of these concepts. And so if you have any specific questions or specific technical questions, please do feel free to use the question button in the GoToWebinar, or of course get in touch with us using our contact form on our website, vshn.ch, and we'll get back to you as soon as we can. So as I mentioned, my name is Aarno. I'm the CTO co-founder of Vision. I co-founded Vision 4 years ago because I saw the need of the software operations and software developers diverge, and so there was this void of helping developers to get their applications running and operation on any infrastructure. And that's what I founded Vision for, and of course our product APPUiO, which is now in its 3rd year in production. That has been a very interesting path for me personally, of course. Also, growing company from 8 to 30 Visioneers is of course a challenge for that as well. And before that, I was co-founding Atrela, and before that, I was at ETH Zurich with an internship at Google Zurich, which was of course very interesting. So if you have any questions regarding operations engineering, and of course DevOps, please do get in touch with me and ask me questions. So let me introduce you to the dilemma between software development and software and IT operations in general. So from the perspective of software developers, they are measured by the amount of new features, of new functionality, and the speed in which they get that functionality out to the market, out to production, out to become visible to customers, right? And so the pressure from the business, that can be marketing, that can be product owners, is of course to push them to be faster and faster, because also of course because most are in an online business, in a competitive business, which their competitors are bringing out new features, they're bringing out new functionality, which they of course need to adapt to and of course be better in the market. And so the release cycles are becoming shorter and shorter. That means that the time between an idea and then the time you need to code it and the time it takes to get it to production, of course, that time needs to be as minimal as possible. And that, of course, means that doing those deployments, bringing out the code, updating the code of your website or software as a service or e-commerce, or if you're a big media company with many websites, or a digitalization project with customer portal, or even a mobile app API backend. I mean, all of those are becoming more and more popular, and of course, by becoming more popular, the quality and the performance is becoming more and more important and relevant, right? And so from the point of view of software developers, a lot of times, if the company decides to host their applications themselves, they'll have to wait for the operations to resolve issues, to make deployments, to adapt the infrastructure to new needs, to new features, right? And that, of course, is a hindering, right? It's hindering their speed. It's hindering their way also to show off their new features, their new functionality, because they're already coded, but they have to wait for them to become deployed and become visible, right? And so this legacy IT infrastructure that's needed to make their software run, and of course that's mostly managed using manual labor, stands in their way. And stands in their way as in it makes their progress slower, or even makes it impossible for them to adapt to whatever the market needs from the customer point of view. And so it's almost impossible to optimize an app for these infrastructure set limits and compatibilities. And of course, the frustration for having to adapt to those infrastructure needs, or to wait to adapt to the operations speed or manual laborness, that is of course a frustration, right? And that's not very good thing to have. Now, from the IT operations point of view, there's frustrations as well, right? So instead of being able to focus on taking care of the infrastructure in a proactive way, most of them are very reactive, right? They have this fires popping up, and they have to be firefighters. They have to take care of problems and incidents, of course, but usually, and especially if the infrastructure is managed manually, there is not much time between taking care of incidents and then taking the rest of the time is taken up by the manual labor. And so there's frustration, as in it's not that interesting, right? I mean, doing manual labor over and over again, that's not fun. But it's it's a self-fulfilling prophecy, right? Since you don't have time to automate, you will have to do the work over and over again, and so you don't have time to automate, right? So that's a problem, of course. It's very difficult to get out of. And usually in the IT operations field, the security and compliance requirements get applied, right? So security and compliance is of course getting more and more important, with the application getting more and more important. And of course, depending on which field you are in, if you're a financial service provider, then of course you get hit by those requirements, those mounting requirements, of course, more and more. And since the IT operations are the guys that have to take care of enforcing those requirements, that of course won't help either. Now, the pressure that the IT operations, of course, feel the pressure from development to be able to quickly provide a suitable infrastructure, and of course, by not having time, the estimated deployment times just get further out and further out, and of course, not helping with the pressure. And the infrastructure cost is of course an very important topic as well, because mostly the operations are tasked with taking care of the accounting, of billing, and of course the internal to take external vendors and build them internally to the right projects. And so with mounting number of projects and with a mounting number of infrastructure, whether it's internal or external, this of course, this bookkeeping of course takes up some considerable time. I mentioned, requirements getting higher and higher. Security and compliance is of course one, but keeping up applications is of course the SLA, the service level agreement, are getting tighter and tighter, because when the applications get more important, they they are required to be online more, right? They are being driven by their own success, and of course that does not make the operations any easier. And both with the getting more complex and getting more having less time to do it, the complexity is of course also a hindrance, both with the manual work, with any work, but also with, of course, with the accounting that I mentioned earlier. So you see, there's this there are these problems that the IT developer, the software developers, and the software operators, they have like they're incentivized on different goals, right? And actually, their goals are very different. Where the IT developers, software developers, are measured by the amount of change they can introduce, and the IT and the operations are measured by the amount of stableness, or, well, not making any change. I mean, these are interfering, right? And this conflict is exactly what we mean by this dilemma, right? And these different goals, they are even opposite goals, right? And so there's a lot of resources and time, of course, being lost there by working in opposite directions. Now, this is not fun, right? Deadlines that pass by because of the time delay, the costs increase because of the friction, the pressure increases because the pressure increases from the business. It's not very agile because it takes a long time of planning, a long time of doing, and then when it's done, then the requirements have changed already. So this is not very flexible way of working and collaborating. And the frustration and the opposition inside the company, even, that's of course a total motivation killer. And so that's not something that's very good long term. Now, with the if you can't meet the SLA, if your application is offline, if the customers feel that, and of course, as customer satisfaction decreases, even if it's a very visible application, and even the reputation of the whole company can suffer. And so these are, of course, problems that need some proactiveness, right? This is something you need to do proactive. And even if you can get all of these challenges, if you can meet all of these challenges, the competitive advantages remain unused, right? If you don't have time to be proactive in change, if you don't have time to be proactive in improving your system, your software, then of course you don't have time to be competitive and to get competitive advantages, right? How can you change that, right? How can you get out of this problem? Well, the solution is DevOps. DevOps is the word that describes the collaboration between development and operations. And so this collaboration has many aspects. It has, of course, a technical collaboration, technical tooling, some common processes, but it is also a very cultural, people-focused change, right? Because to make sure that the teams do not have opposite goals, you have them to be active to collaborate, right? And that's, of course, a people management problem. And so from a process point of view, the DevOps means that the collaboration between the the planning and the coding, the building and testing of software, which is like the standard software development process, is connected to the releasing, deploying, operations, and monitoring of the traditional operations processes. But since they are so interconnected, they need to work very closely together. So, for example, from this software artifact that developers are building, the release and deployment is, of course, something that there's a lot of operations know-how involved. But that's, of course, something that they have to work very closely together anyway, just on a technological packaging, deployment automation front, right? And on the other hand, from the whole experience of operations, with all the data that comes out of monitoring, with availability and other metrics and KPIs that you need to track, of course, these feed into the planning phase of the code, right? I mean, if there's a stability problem in the code, then of course that's something that you need to learn and adapt to very quickly, right? And so this culture of collaboration, of profiting from each other's tools and and making this process together, that's a culture, right? This is a culture of collaboration that needs to change on a company level. That's not something. That's not a tool you can buy. It's not a product, right? If you don't align those teams, if you don't set them common goals, then of course this will not work, or we will have the same problems as before. And so this deploying of pushing a new version of a software over the fence to the operations for them to take care of, that won't work, right? Because both will need to have the goal of having their website or application or whatever it is, having it available and having it updated, right? And so both are involved in operations with having it available, but also developers to, of course, not build unstable software, and of course developers pushing out new features, new versions that then operations need to take care of, having a safe and always available deployment process. So this collaboration culture, that's a very important thing. And that's actually also how we see, we at Vision see how this sort of process could look like. So from a software development customer's point of view that develop software and version management, which is usually Git nowadays, we feel, and that was pretty new 4 years ago, that the whole description of what the software needs to be able to run, so what kind of application server with which version, what kind of databases, what kind of web servers, cache servers, whatever the application needs to be happy, that of course that should be written down in an automated way. That means written down in a code, and so specifying the infrastructure the software needs as code, infrastructure as code. That's something that was very new. And that's of course something that has a lot of advantages. So to specify the infrastructure in a code, and of course keeping the code for the software and the code for the infrastructure together, that of course helps you to use the same software engineering processes for developing the infrastructure as well, right? So if you want to change a configuration element, like the version of the application server that your software uses, well, that's the same kind of change as a change in a software feature, right? Because it's the same style, it uses the same process, it uses the same tools. And so, for example, to change the version number of your application server, you would just change the number in the configuration. You would check it into the version management like every other change as well. You would, for example, make a feature branch if your development process looks like that. That feature branch would be built and tested like any other feature as well. And so this changes in infrastructure would use the same processes as any other change. And so the process of making change becomes a very natural process, right? By automating this change, also the changes can be smaller. And of course, with smaller change, there's less risk of breaking something involved. And of course, with less risk, of breakage, the quality becomes higher, and of course, the stability becomes higher. And higher stability, I mean, that's a win-win both for developers and the operators. And also there's many more benefits. So having an automated configuration management, of course, helps you to have many more testing instances. So for example, you can provision a local virtual development environment for each and every developer on his and her laptops, right? And so they will never ever have the problem again of it works on my machine, but it doesn't work on the server, because they will have a small server on their laptops. And so they can what they're testing is what they're getting later on these servers as well. And so this, of course, makes sure, enables them to produce better tested software, of course, again, with higher quality. And that's a good thing in itself. And so this is like this feedback loop, this self-improving process that of course, that helps everybody involved. Now, continuous integration has been in software development for a very long time, 20 years and more. And of course, now using this continuous integration process and this continuous integration tooling and technology for infrastructure as well, that's pretty new. And so making sure that the whole team gets feedback from the continuous integration, from the testing of the software, and for each change of the software and infrastructure now, that's of course something that everybody then can be on the same page. And deployment that does not meet the tests will not get deployed, of course. And so all hands on deck can focus on improving that release until it passes the tests and can be deployed to a test server, for example. Now, with the servers and all the required databases and backends and whatnot, by the configuration management, of course, the software stack on the servers matches the one on the testing environment and in the development environment. And so all these problems of different versions of different application servers can be eliminated, and that of course helps reduces risk as well. Now, that's the development and deployment process. That's of course something that traditional operators have not involved themselves in before. And with this collaboration of the configuration management and using the version management and the automation, of course, for setting up all these servers, virtual or physical or cloud, it doesn't matter. That's of course this collaboration aspect that helps them to do this change together. And of course, anybody with access to the version management, so developer or operator, can of course improve this and improve this process and can do required changes as often as needed, right? So this is a very collaborative aspect. But of course, the rest of the software operations processes, those are still the same. So these software in production at least need to be monitored and alerted with 24/7 if needed. Then of course all the logs of the software, what the data information the software produces, with all the metrics and KPIs, no matter whether it's like number of visitors per minute or the turnover of the e-commerce shop per minute. That's of course this is information, this data needs to be made available back to the team, for the team of software developers and product owners and the rest of the business, of course, to be able to make informed decisions about how to continue improving their software, right? So providing these kinds of information, this kind of data back for them to get information out of it via a dashboard or however, that's of course a very, that's the second arm of the operations and developer collaboration and feedback loop. Right, and so these feedback loops, they keep on improving the software and they keep on improving the collaboration, and that's of course something that we feel very strongly about. Now, what is this DevOps and how does it help with cloud and containers? Now, the DevOps philosophy is to eliminate for the collaboration to be efficient. Of course, the idea is to automate the recurring tasks as much as possible. And of course, this makes it cost effective and lean, and you can use those automated processes then to be agile and to respond quickly to changing demands. Now, this is something that resonates very closely with the idea of cloud, right? So to use this automation and to use this collaboration and of course also for the developers and the operators to focus on their core competencies but still collaborate, that's the same thing with the infrastructure, right? So no matter whether it's the infrastructure as a service, use a platform, or even use the software as a service, the same concepts of automation, of collaboration, of bringing security and flexibility through the automation is of course also in focus. And so switching to the cloud does not only mean that you just move, stuff around, but also changing the philosophy of thinking about what is our common goal, right? How do we collaborate as a team to bring the company forward? And this, of course, the container technology is one of these tools that can help you to in both a DevOps, but also in a cloud transformation project. Now, containers are a packaging format. That means that you put your application code, you put all that's needed to run the application that you need to specify in the configuration management. So all the application server with all its plugins and extensions and libraries and everything, you put it into one package, and that package is called a container image. And now the container image does only contain the application and its dependencies, but is not a whole server, right? So that has a few benefits. First, to run your application, everything is included in that package, but you do not have to take care of the rest of a infrastructure of a server, of an operating system or kernel or stuff like that, because that's outside of the container. But still, the container has a very well-defined list of requirements. So how does the software get started? Where does the software store its data? How does one then access the software running in the container? And that container can then run on any infrastructure and on any kernel, almost on any operating system, with the point being that everything the application needs to run is already included. So the dependency management, so the taking care of what is needed on the server for the application to run, which version of application server and stuff, and which database, right? You already provide that information inside the container. And so deploying the application is a lot easier because you just have to deploy that container and not have to care about the whole environment anymore, because you provide the environment. And of course, since those containers can be built and started and rolled out automatically, the whole process around the container is already there. That of course helps you to not have to reinvent the wheel of deployment like over and over again for each and every project. You can do the deployment once, or there's actually a few that are already available, and then you can use that for any application that you can put into a container, and don't have to re-engineer that. And of course, since the containers only contain your application and not a whole server, they're way leaner, so they start faster and they use less resources. So that's actually a good thing. And they are a very generic way. So most, like in logistics, right? I mean, containers are standardized, so they have like these four corners. You can lift them around. You can put them on any infrastructure, any ship or car or a truck or a train or something, right? The container doesn't care. So as long as your product fits into the container, you can use the whole worldwide shipping and logistics process without having to care about specific place, the specific way of transportation, for example. Same thing for software. And so the best known container technology is called Docker, with the small fish, and of course having always this shipping container visual image, and then the tooling around that to be able to do this deployment automation and the whole management of different containers. That's where Kubernetes and OpenShift come in. So what does that actually help you to do? Well, as soon as you have it's like in logistics, right? Putting your product into the container, of course, takes a little effort, right? Takes a forklift or something. And in software, it's very similar. Once to specify the contents and the method of how the software gets into your container, but from then on, you can use all the automated software that's already there. And so to be able to use those ready-made processes and tools around that of course increases both reliability, because those are already tested and battle proof, but also your flexibility and repeatability, right? These container technologies, that's an open standard, it's even open source. You can use them for free if you want to, but they run on, and it's cloud native, but not cloud only, right? They run on your laptop the same way they run on your server in your basement. They run in the same way in the cloud. And so this makes it a lot portable. And of course, that's portability helps you to save costs both through the automation, but also to not be locked in to a certain environment or a certain vendor. Now, how can you go and migrate your applications to the cloud? Well, let's look at this from a high-level process point of view. So first, you need to make an inventory. You need to make an inventory of your applications and what kind of environment they're currently running, right? This will take some time, and let's get into it in more detail. But this is to have an inventory is really important, because you cannot just start do stuff before you have a whole picture of how it's interconnected, right? So the second thing is to educate your team, right? Your team needs to be on the same page of migrating to the cloud, or at least evaluating that. And of course, if they don't have the necessary know-how to do that, then of course find a partner that can help you with the experience to, for example, knows the different cloud providers and their strengths and weaknesses, and can of course consult you in the specifics, also into technology field. Then once you have a team and an inventory, then you can go and choose the right cloud platform or cloud provider. That's of course the same thing with a partner for the infrastructure, for the cloud services. That of course needs to be able to make then the specific decisions of how to implement, how to migrate and stuff, right? And this is the next step, to plan the migration, how to do that, what comes in what in which way around, and then just executing that migration plan. So migrate step by step, and then of course putting them into the maintenance, and of course automate that as far as possible to bring down the OpEx, the cost of running them then actually on the cloud, right? So this is a very planning and executing the plan process. So let's go into a little more detail, right? So to understand your applications, you have to first, of course, write down what they do, but also how important are they? And of course, the importance can come out of the how they are interconnected, but also who uses them, right? If they're customer facing, they have probably a higher importance than, and they need a higher SLA, they need a higher availability than an application that's just used internally, or that's used very seldomly, right? Then sort them by the workload if it needs change, right? If the application needs to be adapted, or if they need to be changed in somehow, and then make a migration strategy for each of those applications. I'll come to these different ways of migrating in a few slides. And of course, it does not mean that you have to make one migration strategy for all of the applications at the same time. And of course, what you should do is evaluate the best strategy for each and every one of the applications. And of course, one of the decisions can be to not move an application, right? And so how to migrate? Let me, I'll take Gartner as an independent partner to evaluate those. There's 5 options, right? There's rehost for infrastructure, there's refactor for platform, there's rewise, and then rebuild or replace completely with something else, or a standard or off-the-shelf product or service like software as a service. And like Richard Watson, the research director at Gartner, puts it, the just move to the cloud is actually a pretty hard engineering problem, and there's quite a few different ways and different facets how to do that. And so the migration planning and the 5 steps that we talked about before, that's not something you would just go and move, right? You have to actually look at that, and for that you need skilled staff, skilled IT staff, think about the whole, how the applications work together, the application architecture, and of course then the technical, the doing, the actual migration. And so the 7 different ways you can actually migrate is first a rehost. Just take the whole application environment, the whole server basically, and just move the server to the cloud. Well, that's very easy. That's also pretty fast. But the problem is that if you move this, and I'm assuming it's an older application since it's already running, right? You move this this legacy server just one-to-one to the cloud. You get rid of the infrastructure, you know, the physical infrastructure, physical server that's running it. But also you're not gaining any more flexibility or that, and you just, you know, you'll continue to pay for it, which of course may be a valid option if you plan to retire the application in some years anyway, or if it's just if there's no time to do it, or there might be valid reasons, but it might not be the best, right? So the second option is to refactor. Refactor, re-architect. That means to look at the systems architecture of an application and taking out certain parts, right? So for example, to not move the whole server, including database and application, everything, but to just move the application and then use an external database, for example, a database as a service. That of course brings down the cost of maintaining the server and the cost of maintaining the database if you can use a service for that specific component and use the rest of the application as is. The next path is to revise or replatform. That would mean that you would actually not only refactor the systems architecture, but you would also take the actual software and take it out of the old server and putting into a new environment, for example, a container-based environment. And now, of course, if the software is being continuously built and updated by yourself, then of course you will also have the know-how to actually take the software and put it into a container. If it's a legacy application or a standard application you bought from somewhere, then of course that becomes more difficult if it's like a ready-made container. The fourth option is to rebuild the application from scratch. So to discard the previous code and then build a modern application using also fulfilling your current modern requirements, and of course putting it into a modern platform that enables you to then continuously improve on that later on. It's a very harsh one, right? So to just discard your old application and build something new from scratch, but it might be for very old applications and stuff that you is bound to a certain piece of hardware or something. That's of course not going to scale and not being, you're very locked into that. That might be a good way also to skip over like a technology change by just rebuilding it with a modern technology. The fifth migration path is interesting because it's replace the old product you're having right now with a ready-made software as a service solution, cloud solution. So for example, instead of moving your old in-house CRM to another infrastructure, you replace the purpose of the software with a software as a service that's made by somebody else, that's maintained by somebody else, and that's actually even run by somebody else, like for example, Salesforce. So you would discard your old CRM, you would of course migrate the data, and then you could use the salesforce.com online platform without having to care about the continuous improvement of the software that's in it, and you could just keep on hacking on the data. And of course, that might be a lot cheaper and faster in the long run than to keep on building up a standard software that's available else already. And then for completeness, the two last, the 6 and 7, to retire an application, if you find out in your overview that an application is no longer needed because it's just sits there and nobody uses it, or it's just not important anymore, you can actually just retire it. And that's of course the largest cost savings, right? Because then you don't need to touch it any further. And of course, the seventh option, to retain, is to just leave it be for the moment. For example, if you know that you won't be needing it in a year's time, or just reevaluate later. That's of course always an option. And so one of these options is probably the best one for each and every one of your applications. And the same thing in a graphical way is, make the inventory, determine how to migrate, and now depending on the how to migrate, retain, not move, retire, decommission, or rehosting. It's also called lift and shift. So just taking the whole application environment and just moving it into new infrastructure. Hopefully using automated tooling to just move it. You can also do it manually, but of course that's digging a bigger hole for you to spend money on, because if you can't use the stuff you have already, but you have to do it all over again, then I would not recommend you do it manually, because that of course will take you a lot of time in the future for maintenance, right? So if you plan to rehost, then do it automated, and of course validate that the migration worked, and then you can switch over to the new version and use that in production. Now, if you plan to re-platform, if you have already made software and you just continue using that software but not use the whole environment for it, then of course you can determine the new platform, for example, container-based platform. You can modify the infrastructure. That means making sure the software runs in the container, and then use the automated migration tools of deploying the container to the container platform, validate its success, again switch over to the new version, and then use that for production. Repurchasing, that's the replacement of a standard software. You would of course have to purchase, to choose which is the perfect commercial off-the-shelf or software as a service offering that would be you, and then of course to install that, automated if possible, validate, transition, and move to production. And then, of course, if you are currently still developing that software, then you can actually have the software developers go and refactor, rewrite the application in a way that it's the infrastructure architecture, the systems architecture is scalable enough, and you can use the most modern services like platform services or even serverless technologies. So those need to be developed into the application code, and then with the application lifecycle management, automation integrated into the cloud environment, and then of course make sure that it still works the same way as before. So this is like the same thing as before, but just in a way how the different processes work together. Summary. So focus on the software. Focus on how that software helps your business. Focus on how that helps the customer. And of course, by focusing on the software, the faster you get to produce better software for your customer, the better it makes your company future-proof and agile to changing customer demands as well. And of course, that's something that can be enabled by DevOps. That's something that can be enabled by cloud and container technology, because both or all of them bring the agility and automation to the table, which of course helps you to achieve these goals, right? And so to focus on the software development and to not do the work that's already there with standard tooling, with standard infrastructure, that of course helps you to focus all the resources on your customer and not solving other problems in the meantime. So In my opinion, DevOps is the key for the digital transformation of software development. If your company is in a digital transformation of your customer loyalty or customer communication, or if you're in your core product even, like software service or e-commerce, then of course DevOps is the key for the future-proofness of your company. So how does APPUiO, the Swiss Container Platform, help you with that? So APPUiO is our product that we made together with Postlatisi in Bern. It is a cloud service. So you get the Docker, Kubernetes, OpenShift that I mentioned earlier as a ready-made service in Switzerland, but also worldwide. We're running in 14 countries now. It's already there. That means the time to market is extremely fast, and you can go and create your account yourself, and you can deploy your applications yourself. And of course, this fosters the collaboration because your developers can actually go and do stuff and not have to worry about the underlying infrastructure, because that's something that we can take care of for you. It's ISO 27001 certified. It runs in Swiss financial markets regulator approved data centers. And of course, that by doing that at scale, and we do that for 300 customers now, that reduces cost. Now, one of our customers that use that platform is Kuba. So Kuba is a Swiss software company that makes standard software for the insurance industry. And so they do that for a long time. I mean, their application Sirius is 20 years old. And of course, for them, they have the challenge that they need to be able to deliver their software on any infrastructure, right? Because their customers want to run it, each and every one of them wants to run it on their own infrastructure, whether that's on-premise or in the cloud. And so they had to find this abstraction layer to be able to develop for their own development environments, but also for running their customers' instances themselves. And so what they did is they actually put their 20-year-old software, they re-platformed it, they put it into a container, and now they'll be able to just push that container to the standard container platform APPUiO that uses OpenShift and Kubernetes and Docker in the background. And so that, of course, for them helps them in the cooperation, both with their internal developers, their internal operations, but also their customer operations, right? And their customers like Helsada, Concordia, Visana, Suba, which are the largest Swiss insurance companies, they receive a new version of the Sirius platform with the containers, which of course all include all that's necessary to run the container, and that's of course a lot less support because they can run it on any of these. If they have it on premise, they can run it on the same infrastructure on any infrastructure they already have using the OpenShift and APPUiO technology. And so of course Kuba is really happy to have found this, and also they're very proactive with showing that. So if you would like to try out this container platform, please do try out this voucher code. We'll send it also to you in by email later on. APPUiO webinar in 2018. Please mind the large and small caps, and you can enter it at register.appuio.ch to receive your testing account for 30 days for free. Have fun. Now, any questions? So I got a question. Why should I use APPUiO and not build my own container platform internally? Well, that's an excellent question. There's a lot of pros and cons for that, right? So the first is, of course, that using APPUiO helps you to focus on the software development, and you can use the standard platforms for your development even, right? And since it's a standard platform, even if you decide to use the time and energy of your team to build up a container platform internally later on, you can just move the containers to your own internal platform. So it's like if you want to start with shipping containers, you don't have to build and own the ship in the first place, you can always decide later on to insource that at a later point in time. So I would recommend you to do it with a standard platform to speed up your delivery. So to be faster in the market, to be able to focus on doing the software, and then if you want to optimize on cost or location or internal external, then of course you can always do that later on. Any other questions? Oh, so another question. So APPUiO is basically OpenShift, or what other services does it include? So yes, APPUiO is OpenShift as a service, which you can have on any infrastructure. You can have it in the cloud and also on premise. And it includes both the Red Hat OpenShift Container Platform, the enterprise version, but also it includes all that's needed to make it into a service, right? So it includes monitoring, it includes backup, it includes SSL certificates for you to be able to access it, right? It includes the whole integration into the load balancers. It includes all the needed APIs for you to integrate it into your development workflow. So that's all on top of the Red Hat OpenShift. Plus, what we have is the whole management and internal billing of the different projects and the different the resources. That's of course something that we can add to the table. So as an internal IT service provider, you then know who accessed what and who used how much of the resources, and of course allocate the cost to them as well. So, and then we have another question. What is the added value of APPUiO in versus EKS, so the Elastic Container Service, or the Azure Container Service, or the OpenShift Online Platform Solution? Excellent question. Very technical, but I'll get into it. So OpenShift is a Kubernetes distribution, and it's a Kubernetes distribution that runs on any cloud infrastructure. Now, EKS, the Elastic Container Service by Amazon, only runs on Amazon, and the AKS, the Azure Container Service, only runs on Amazon. So these are bound to one platform. And the OpenShift online platform also just runs on Amazon and not on any other infrastructure. Now, the value of APPUiO is first, we run it if you want to have it in countries where neither Amazon or Azure are running, we can do that for you. So we run in Switzerland, for example. That's not neither of them are in Switzerland or Finland or South Africa. And so there's a lot of countries that are not covered by that we can offer. The other thing is that the APPUiO is a cloud independent. So actually we can deploy that to both Amazon or Azure or Google or to your internal infrastructure. And that's of course not a benefit that the others do not have. And else it's the OpenShift is just another Kubernetes distribution, like the EKS is a distribution. Well, it's actually a service distribution like AKS as well. And of course, the main difference between OpenShift as a Kubernetes distribution and the other distributions is OpenShift already includes a lot of additional auxiliary services. So for example, both the logging and the metrics and the deployment and the container building and the web GUI to manage all of this, that's already included in OpenShift, right? And with EKS or AKS, you will have to build your own containers by yourself. You will have to make sure how to you will have to provision your own Elastic Load Balancers or stuff like that. And of course, then make sure to integrate your application then into an Amazon specific or an Azure specific logging and metric service. That's all stuff that you have to do yourself on top of just using the EKS or AKS solution. So coming back, the main difference for APPUiO is that you can choose where you want to have it. You even can have it on Amazon or Azure. And the additional benefit of OpenShift compared to other Kubernetes services is that there's a lot of services already included, already fully integrated, that you don't have to care about. Any other questions? So we have 5 minutes for demos. I can do a short demo of the of APPUiO and of OpenShift Container Platform for you. If you have any other questions popping up, I'm very happy to answer those as well. Just please do get in touch. So this is how OpenShift and the APPUiO web GUI look like. You see there, you see that you don't see a lot because it's pretty empty. And so please let me show you how easy it is to deploy an application using Docker, Kubernetes, and OpenShift. So I have an application here that I developed myself. It's a small, you see, it's a small Python application. That's my language of choice. You see there's 20 lines of code, so it's not really complex. And so let me show you how to deploy that using Docker and Kubernetes. So I copied the URL to the source code, and since my source code is available publicly, that of course I don't need to authenticate, put in any username or password and stuff. Of course, this also works if you have a private repository somewhere. Now, the OpenShift already includes tools and builders for a lot of different software platforms. So, for example, both .NET Core, but also Apache, Django, PHP, JBoss, Java in different versions and versions. All the JBoss enterprise beans, then regular tooling like Jenkins, databases like MariaDB, MongoDB, MySQL. They're already there. Perl, PHP, Postgres. And so since I'm developing in Python, I'm going to use Python here, right? I can have some ready-made versions, and of course I can provide my own. I'm going to use the provided 3.5 version here, and I'm going to call my application webinar. And here I can enter the URL of my source code and just push create. And actually, that's already it. It has now created a new application webinar for me. The webinar has no deployments because the software is being built. And you see down here, you see the build number 1 is running. It's downloading the source code from GitHub where I have it. It installs all the necessary dependencies, all the code that is needed to run my application. And that, of course, takes a few seconds, about 50 seconds. As soon as all the software components are installed, it pulls them together into the container. That will take a few more seconds. And now you see it created the image, and now it's pushing the image to the platform. And that already happens in the platform, right? So the whole making the Docker image of your software is already fully automated here on this platform. And now that the image is readily built, it gets deployed automatically. You see it's running now here in one instance, and it actually generated here a URL for me to go and test the application myself. And here you see it says hello world. Yay! Well, actually, that's all the application does. It says hello world. I mean, that was a very easy and short demo, and I have 1 more minute so I can show you. So, for example, all this scaling and load balancing, that's already something that you can now use the features of the platform. So now I just scaled it from 1 to 3. You see now there's 3 instances running. The first one is running on server 40, and the second one is running on server 38, and the third one is running on server 33, right? I mean, there's over 40 servers running in this cluster, and you are already distributed over these servers. If one fails, they just keep on running the rest, and you get to restart it automatically. You see here all the information, how it was built, how it was deployed. You see what is happening inside the application. You can actually connect into the application and do manual changes or one-off jobs. And so all of this is already included in the platform, and that's all of these processes. Let me go and actually, you see there the URL of the test URL that was HTTP, and HTTP that's unsecure, that's not encrypted. So let me just add encryption to it. That was actually already it, and now it says HTTPS, which is the S stands for security. And now the same application is suddenly available using encryption and has the padlock here, which means that that's all it needed, and we provision SSL certificates in the background automatically. We have also a wildcard certificate in there that we use Let's Encrypt for to provision that. And so all of these operations, scaling, load balancing, encryption stuff, that's there already for you to use, and you don't have to do it yourself. That was a really quick run through. If you have any questions to that or to the rest of the presentation, and you see, I mean, it took a few minutes for me to build and deploy that to the platform that runs in the cloud, and that could run in the cloud for you, or that could run on your infrastructure, of course, as well. If they are normal questions, then I'll thank you very much for your attention for this webinar. If you do have any other questions, then please do get in touch using the contact form. And oh, now I have another question. How easy is it to connect to external applications like Active Directories? Oh, that's an excellent question. So it depends, right? So if your external service is available to the internet, so if it's an Active Directory, how is it called? An Active Directory, the SAML endpoint, the Active Directory web service or something, then you could just then you can use it instantly, right? So if your application needs Active Directory, for example, for single sign-on or stuff like that, then you can just redirect using OpenID or a SAML, just redirect to that URL. The user gets authenticated, and then it gets redirected back to your application, and you can do that from anywhere. If you need special internet connections, like for example, VPN, virtual private networks, to connect to that, then of course you would need to connect the cloud platform and your internal network through that VPN, and that's of course something you need to do first. And that one you can do both with cloud-hosted private clusters, but also with and connect those then to on-premise infrastructure to have this secure network in between. What you can also do is to connect the container platform itself to central services like user authentication service, Active Directory. That would mean that the whole user and password management of your users, of your administration users, could also be centralized using Active Directory, and that's of course something that helps as well. Any other questions? Thank you for your attention. Please do get in touch on our website or by phone or email, or please come forward and reach me. Thank you, and have a nice day.